So welcome to the second part of my presentation on sports nutrition. In the first part, I talked about dietary supplements, which ones potentially are effective, how you rank them, supplement research, problems within the dietary supplement industry. And in this particular session, I'm going to talk about supplements that work or you should consider using. And I'm also going to talk about some novel supplements and supplement research that I have done. So these are dietary supplements that I think you should think about using. Certainly for strength and power athletes. At the bottom there, I've got protein powder as well. Protein powder, you can get enough protein from your diet. I work with lots of athletes, however, and vegan athletes, to get enough protein in the diet, it can be a little bit tricky when you're trying to get the macronutrient profiles that you're looking for, e.g. ones which are low in fat and maybe low in carbohydrate, and you're aiming for a high protein diet. That can be beneficial, but really it's more of a convenience thing than anything else. So there are use cases, but the ones at the top of the list here, creatine, beta-alanine, electrolyte, caffeine, and then health support supplements, I think are probably worthwhile using. These fall into the Group A and Group B categories for supplements based on the Australian Institute of Sports categorizing of effective dietary supplements. So A, B, C, and D. A and B are the ones which you really want to focus on. So let's talk about some of these. So creatine. Creatine works. Seems to work. And this is the International Sports Nutrition position stance on creatine. You can find similar things from the American College of Sports Medicine, the IOC. But listed here are the potential benefits associated with creatine. So you see an improvement in strength and performance, single rep max improvements, multiple repetition improvements, improvements in muscle strength, power, muscle mass, better glycogen synthesis, improvement in work capacity, enhanced recovery, better training performance. It seems to work, and it's a very well evidenced sports supplement. Creatine you find in meat, so you could get enough from your diet, but challenging to do at the dosages required to see an improvement in performance. How much should you take? Well, a few different strategies on that. What you're looking at though is potentially a loading phase. This is a traditional way to do it, of 5 to 7 days, 20 to 25 grams, broken into 5 grams, so you don't get any stomach upsets. Or you're looking at around about 0.3 grams per kilogram of body weight, which works out around about 23 grams if you're a 75 kilogram athlete. Once you've done your loading phase, 3 to 5 grams a day. Alternatively, you could just take 3 to 5 grams a day for 28 days, and you seem to achieve the same muscle cell saturation after the 28 days. So the loading helps you get it in your system quicker. Once it's loaded, you can drop it back in terms of the total amounts. So that's creatine, and that's what it does. How it works is like so. You've got an indirect effect on performance. Our body's ultimate energy store is ATP. We get a breakdown of adenosine diphosphate, or rather adenosine triphosphate to adenosine diphosphate. We smash off a mole of the phosphate. That releases energy and it allows contractions to take place within our muscles. We can recycle that ADP into ATP using phosphate creatine. Creatine carrying a phosphate molecule allows us to recycle it and put that phosphate back on. So if we can get more ATP, then we can perform more contractions than if we don't have any ATP. We can synthesize it. You got enough glycine, adenine, we can do that. And you can also see, I mean, venison, beef, pork, salmon, these things all have creatine in them as well. Difficult to get enough. There's also psychological effects as well. People are really interested in creatine from the perspective of, does it reduce dementia? Can it improve mental focus, etc.? There's maybe potentially direct effects as well, though. Creatine might signal within the cell to tell us to make more muscle protein. So you're seeing an indirect effect in terms of more muscle contractions taking place, improvement in performance that way, leading to more muscle mass, but there might also be a direct effect as well. So any strength and power athletes should be taking creatine. People say that creatine leads to an increase in your body weight. So we do have to be mindful if we're working with athletes which have to be lighter, but certainly strength and power athletes, absolutely we want to use creatine. Well, here's a photo of myself. Beta-alanine. So, beta-alanine has been shown in lots of trials, and this is a meta-analysis, to lead to an improvement in performance associated with the buildup of lactic acid. So in things which are less than a minute, results are a little bit inconclusive. So sprinting, 1 rep max lifting, things like this, we don't necessarily see any improvement in performance. However, in exercise lasting 1 to 4 minutes or 4 to 10 minutes, such as, say, lifting weights for multiple sets or middle distance running, for example, 800 meters, 1600 meters, things like this, rowing, swimming, you maybe see an improvement in performance associated with taking this type of supplement. How does it work though, and why does it work? Well, when we get a buildup of lactic acid, that typically stops our body from carrying out contractions. It's the acidity that often does this. However, within your muscles, you've got a molecule called carnosine, and if we can supplement with beta-alanine, we can get more carnosine, and if we've got more carnosine, you can see through multiple reactions, we get an improvement in our performance. But the main reason we see a difference is because carnosine helps our body reduce its muscle pH when we are exercising. Okay, so what we see is in mammals that live in the sea that spend a lot of time underwater, like a whale, huge amounts of carnosine reserves because they see a large degree of lactic acid buildup because they submerge for a long time and don't have access to that oxygen, so they get the buildup of the lactic acid. So this is how it works, the beta-alanine. And it looks like you see after 10 weeks, a significant improvement in muscle carnosine, and you should notice a difference after about 4 weeks. However, you do get something called prickly heat. So beta-alanine, absolutely a supplement that I would recommend sort of people doing exercise between around about 1 to 4 minutes and 4 to 10 minutes. So good for team sports as well, because there's periods of sprinting where you get that buildup of lactic acid, jogging at the same time. So really intense type of activity. I thought I had some slides here on other supplements, but maybe I'll come to them in a little bit. I'm going to talk about novel supplements. This is something I've done a lot of work on. It's Citrulline Malate. So Citrulline Malate, you find it in watermelon in really small amounts. You can see 0.2 grams per 100 grams. So you'd have to eat a kilogram of watermelon to get a gram of the stuff. So practically not possible, really. But you get it in lots of pre-workout supplements. You can buy it directly. And you can see here it's as citrulline malate, okay? Citrulline is the active ingredient. Malate's a salt to help with the storage of it so it doesn't all clump together. Although people have suggested that the malate component could be performance enhancing as well. I'm not so sure. But you can see it's in various different dosages within the different supplements. It works via the urea cycle. So we've got the urea cycle here is in that blue component. That's the crossover, between the TCA cycle. And then the yellow marks here are the crossover with the urea cycle, okay? So waste products are built up as a consequence of exercise, and citrulline helps in the removal of that waste. So we get a buildup of ammonia, that stops us being able to exercise, and we can excrete that ammonia via urea. So if we can do that process more effectively, that's beneficial for helping our recovery. It also helps in the synthesis via the urea cycle of arginine. In fact, it's more effective at increasing blood arginine than just taking arginine. So if you've got citrulline in your diet, then that is a good thing for us to do. So there are two main mechanisms of action. So why would that improve performance? Well, I've mentioned the ammonia. I've mentioned the arginine. And you can see this is the crossover point here. If you've got more arginine, that increases nitric oxide formation, and that improves vasodilation. So that's the indirect effect. If we've got more vasodilation, we can deliver more oxygen to our working muscles. If we can deliver more oxygen to our working muscles, then we see a reduction in lactic acid, which again allows us to exercise more intensely, do more repetitions, run that little bit longer in terms of sprinting at high intensity paces. We can clear ammonia quicker as well, indirectly, never mind just from our improvement in our metabolic processes as well. And then people have also said, well, malate, that salt, we can potentially use it as an energy substrate as well, although I'm less convinced. So the question is, does it really work? Well, we wanted to test this. This was our hypothesis, that maybe that capacity would help us reduce fatigue, reduce blood lactate, reduce force loss, reduce muscle soreness because we can get the metabolic products out there that are wasteful quicker, reduce DOMS, maybe it might reduce muscle damage as well. And then over time, athletes can perform at a higher threshold, leading to improvements in performance or muscle gains. So we've tested this. This is a study that I published back in 2018, I think this was. And what we did was we randomly assigned people to one of two groups. I think there was 12 people in this study that did both treatment conditions. Gave them a 8-gram dose of citrulline malate, that 2-to-1 ratio. We ended up giving them the MyProtein one, so less than 5 grams. We got them to exercise on an isokinetic dynamometer at 80% of 1 minute max, 10 sets of 10 repetitions. Okay, so that's what he did. 1 minute rest between. And we counted how did they get on in terms of their repetition performance over time. How many reps do you lose? We also measured force generation eccentrically, concentrically, isometrically. We measured blood lactate, muscle soreness, and dietary intake. Randomized, crossover, double-blind, placebo, counterbalance trial. This is what we found. So over time, citrulline malate had no difference in terms of the effect on reps people could perform from set to set. So doing your German volume training, it didn't seem to make a difference. Although results are individual. Force production, no improvement in isometric, concentric, or eccentric. No difference in terms of rate of force production either, so you can't generate that force any quicker. No difference in muscle soreness. In fact, people taking citrulline malate got even sorer at the end of the day. No difference in blood lactate concentrations either as well. So in terms of our hypothesis, no results. Didn't seem to do anything. So we thought, do you know what? Other studies have shown an effect. Maybe we did something wrong. Maybe it's because we had less citrulline malate than we thought. Maybe we need to try it in an upper body situation rather than a lower body and see what happens. So we tried it again. Looked at 10 sets of 10 of our German volume training. This time we did bicep curls, measured blood lactate, blood creatine, kinase, which is a marker of muscle damage, muscle soreness, and then we looked at dietary intake. Young men and women. So, what we found was citrulline malate and our placebo, no effect again. After 10 sets, people are doing less reps, no discernible difference between the two. Muscle soreness, there was a difference here. However, in the last study, it went in the opposite direction. So maybe it's worse for your legs, but better for your arms. Measuring blood lactate, absolutely no difference. No difference there. So if there was a reduction in muscle soreness, it's not to do with the change in lactic acid. So that was our second study. We gave a higher dosage, so we got up to the 6 grams. What happens though if you use more experienced exercisers? And also, what happens if you load it like creatine? That was our next thing we were kind of really interested in. So what we did was, we repeated our first study, and this is published now. Another randomized double-blind placebo-controlled trial using an isokinetic dynamometer, so we measure force production, measure muscle soreness, recruited rugby players, so they were more trained than our people we had before. And then we wanted to say, okay, well, we gave them a 6 gram dose over 4 days. So we really loaded the citrulline malate here to see if we could see a difference in our performance. And we subjected them to that crossover trial again because we wanted everyone to do both conditions, placebo or control. Should mention that across all the studies, the supplement was well tolerated. So this is what we found. No real difference in rep performance again. So there's error bars on there. You can see that there's a lot of crossover between the two. Eccentric, concentric, isometric force production, no difference in performance. So people are not doing better with and without the supplement. Rate of force development, you can't generate any more force here. No difference in blood lactate, no difference in creatine kinase. We also measured arginine and citrulline concentrations. They improved, but not significantly. So maybe we need to give even more. And then again, no difference in muscle soreness, again, on the legs. So different results compared to the previous study. So a loading dose of citrulline malate had no effect on fatigue, resistance, or performance. Citrulline malate and arginine increased, but it wasn't significant. So maybe, like I say, we need to give more. So next thing we were thinking is, well, maybe give a higher dose, maybe try an endurance setting rather than lifting weights to see if it improves based on our beta-alanine example, which is 1 to 4 minutes or 4 minutes to 10 minutes. Maybe it works there. And then what happens if you take a well-trained bodybuilding population with 5 years of lifting? Because before we did this, we did it on rugby players, and I mean, they lift, but maybe they don't lift enough. That would be an interesting thing to look at. So in terms of novel supplements, we've done probably the most research on citrulline malate. And these are questions that throw up. Maybe it works on highly trained individuals. Maybe it works with a loading dose. Maybe it's more effective for endurance training and not resistance training specifically. In terms of endurance training, it's a mixed bag. There's not enough there to prove efficacy, and citrulline is likely the most bioactive ingredient. But this is one of the most used supplements on the market, and there doesn't seem to be a whole lot of evidence to support the use cases for citrulline malate. We find it in lots of pre-workout supplements. Now, use cases for another 5 novel supplements. So these are novel ones which might fall into that C and D category. We've got testosterone boosters, branched chain amino acids, and other individual amino acids. Carbohydrate gels and drinks, I mean, these are not novel. We've got ashwaganda or nootropics, and then you've got fiber, prebiotics, and probiotics. So why might you use these? Well, testosterone boosters, like I say, are high risk. This is where people are most likely to fail a drug test, as if you're taking a supplement like this or a fat burner or a pre-workout. And to be frank, in a lot of cases, they probably don't work. And that's because testosterone generation is based on this negative feedback loop. So our hypothalamus tells our pituitary gland to release follicle-stimulating hormone and luteinizing hormone, which signals to our testes and tells us to produce testosterone. Once testosterone is released, there's an inhibition effect which goes to our pituitary gland and our hypothalamus that says, you've got enough testosterone in your bloodstream, switch off this process so that we can regulate it, because too much testosterone is not actually that good for us. And that is why when people take testosterone, males that is, their testes shrink, because they've got an exogenous source, so their testicles don't have to keep producing testosterone, right? But there might be circumstances in which they might work. Maybe it might only work for a very short time. And instead of taking a testosterone boosting supplement like Tribulus or bulbine extract, maybe you take it every third day or every second day. And that gets past this scenario. However, you'd need to really test it and test your bloodstream and see, okay, what's happening with testosterone. It's not really clear which dosages you need. How much is effective? If I was doing an exercise trial on this, or nutrition trial, I'd give more to see if it works, rather than less. When it comes to people getting ready for events, very often they overtrain. People get very low body fat levels, and there's a recovery period whereby their testosterone levels are potentially low. This is a potential use case in which you could be taking something like this just after competition to boost those levels and get you back to normal hormonal function as quick as possible. So there's a place where you might want to think about it. Research which has been done on this. So this is a trial looking at 52 different reviews on testosterone. You can see all the different, testosterone boosters. You can see all the different types of testosterone boosters which are out there. So you've got a huge amount of heterogeneity. You're talking ashwaganda, tonka ali, terkesterone, HMB, tribulus. So no, it's not even specific to a particular type. So it's hard to say, does it actually work or not, right? This study of systematic review, looking at all these studies, says it's actually largely ineffective. However, in hypogonadal men, so men who have got issues producing enough testosterone, or infertile men, you maybe see a difference. So that's their use case, like I say, post-competition. What about branched chain amino acids, essential amino acids, or even leucine? Well, I've mentioned vegan, vegetarian athletes before. The thing about a diet which is rich in plant-based proteins and does not contain animal-based sources is that it can be limited in essential amino acids. The great thing about essential amino acids is via this pathway here, the mTOR pathway, leucine directly signals on the outside of a cell and tells your body to produce more muscle protein. That's how it works. It tells our cells to produce more muscle protein. And if you have a diet or an exercise challenge whereby you give someone either whey or egg or soy or wheat, and you measure muscle protein as a consequence of this, we see that the whey and the egg protein has a positive effect on muscle protein synthesis over and above anything you get from the soy and the wheat, despite the fact that the protein amounts are matched. So in each case, they're given the same amount of protein. It's just that the amino acid concentration is different. However, the other graphic that I can show you down here, where they're measuring protein synthesis, if you give wheat protein and you compare it to whey protein, and you measure protein synthesis, whey comes out on top, even when the amounts of protein are matched. However, WGL there, if you give wheat protein and leucine, the same amount of total protein, and you convert it to whey, you can match the equivalency. So people have argued that this might be a reason why you see a difference in muscle mass between vegetarian, vegan athletes and omnivorous athletes because of this net positive effect on protein synthesis. So this is an example of whereby if you took a vegan-based athlete or vegetarian, we might want to add more leucine, essential amino acids, example, to a diet to improve calorific efficiency. Another example where you might want to do it is in time-restricted feeding or fasting. If we're going long periods of time without consuming any calories, we end up in a negative nitrogen balance and we risk losing muscle mass. So having some essential amino acids drip fed throughout the day, how much you need, I don't know, maybe 10 grams in total when you're not eating, might offset this problem because you're stimulating muscle protein synthesis and you maybe use the other amino acids you have from the net pool. Long distance endurance events, so we're talking ultramarathons or marathons, maybe drip feeding amino acids during here might reduce muscle soreness to offset problems caused by long duration activity. However, if you've got enough protein in your diet in general, e.g. 2 grams per kilogram of body weight or 0.35 to 0.4 grams per kilogram of body weight per meal, it's pointless because you're already reaching the threshold you need to stimulate protein synthesis and getting everything you need. So this is where you might want to use it. Okay, carbo gels and carbo drinks. It's a long history of using carbo gels and drinks in endurance-based sports and stop-start sports. One area which I'm interested in using them though is in bodybuilding and strength-based sports. Now, you can purchase 5 kilograms of maltodextrin for £20. That's £4 a kilogram. However, if you're a bodybuilder, you'd never be seen dead drinking that. Instead, you'd drink cyclic dextrin, which is almost £30 for a kilogram. And there's not a great deal of difference probably between the two for a bodybuilding use case. Because really in both cases, what you're looking for is a product which is going to get into your bloodstream very, very quickly during an exercise session. So again, don't necessarily have a use case for cyclic dextrin because you don't need to consume more than 120 grams per hour of glucose. You're probably more looking at around about 15 to 20 grams. Also, the restoration of glucose at the end of a session isn't necessarily as high in demand because you're not doing multiple events in one day. So you can probably get that from your diet. Carbohydrate loading strategies, however, it's not uncommon for a bodybuilder to consume 1,000 grams of carbs a day, doing this for 3 subsequent days. So this is where you can maybe get a really good use case of a gel or carbohydrate drink, for example. What about ashwaganda or other nootropics? Well, they've been suggested to interact with your immune system, reduce depression, anxiety, stress. And these are things which all go up when we're working with people who do extreme type dieting. And what we see is from systematic review and meta-analyses is if you consume around about 600 milligrams, so if you can get a product which contains at least this much in it, and you've got a very specific population of 40-year-old athletes, then you do on psychological testing questionnaires see a reduction in stress. Whether or not that translates into young athletes fit and healthy, not following extreme diet protocols, It's a different story. And just because Ashwaganda might do this doesn't necessarily mean that a cordyceps type supplement has got the same effect. But I'm really interested in testing this. Okay, other supplements which are popular are fiber and pre and probiotic supplements. Let's talk about use cases here. Sometimes you might come across individuals who have got IBS, irritable bowel syndrome. So constipation is often seen in people that do a lot of dieting, because very often they might reduce a lot of the fiber content of their diet. So fruit and veg content sometimes goes down, which is contrary to what you might think. But you also see a reduction in carbohydrate. So the carbohydrate is one of the things which helps the food flow through your body. If you're seeing a reduction in things like whole grains, starches, because people are not wanting the carbohydrate, then you will see a reduction in transit time. So adding a fiber supplement can keep people fuller for longer, whether it's soluble or insoluble. Both seem to potentially relieve the symptoms of IBS. Both would potentially be effective at causing beneficial microbes to grow within your gut, and we certainly want this. And prebiotics, if you take a prebiotic specifically like inulin, GOS, for example, might be even better for your body. Probiotics, if you look at the research on this, kind of tricky, because probiotics don't necessarily work, but some of them show that you might see a reduction in IBS type symptoms associated with them. And that might be because a production of short chain fatty acids takes place. There might be some immune support. However, I include this concept of colonization resistance in here. And this is because colonization resistance is one of the main reasons why you don't get infected. So putting something into your body as a microbe to try and improve your health doesn't necessarily mean that it's going to get a spot in the gut. It might be just that you get an upregulation in other microbes as a consequence of this. Okay, the thing about probiotics is that they're all different. It's like vitamins and minerals. You take vitamin C if you want an antioxidant effect, or vitamin D if we want to improve calcium absorption. You don't take zinc, you don't take selenium, for example, for those reasons. And probiotics are the same. There are thousands of species. Within the species, there are hundreds of strains as well, and they don't all necessarily work the same. And that's why EFSA struggles with health claims. There's also lots of different types of fiber as well. So if we're talking prebiotics, just be aware of, you've got things like psyllium husk, you've got apple pectin, you've got inulin, hemicellulose, lignin, cellulose. There's lots of different types, and some of it's soluble, some of it's insoluble. But again, just making a carte blanche recommendation to increase fiber or go and get a fiber supplement might not be effective. Maybe it's a particular type of fiber which is effective. And these different types of fibers cause different microbes to grow. Some might be good for you, some might do nothing. Okay, so there were some examples of novel use cases for supplements, where you could potentially use them. I'm interested in REDs and extremely low body fat athletes. And under those circumstances, it might be useful for something like your probiotic, prebiotic, something like your branched chain amino acid or your testosterone booster in there, right? But it's all caveated, right? I'm not saying these things absolutely work, and are there different places that you could spend your money, right? There's no guarantee that these things are going to actually be more effective and they're going to be anything more than a placebo, right? Whatever you do when it comes to supplements, the main thing is that we track your progress, monitor if they work or not, and if they're not doing anything, then we don't need to use them. And at the end of the day, a healthy, balanced diet is really what should be being met first and foremost. Track your dosage protocols. that you're using. There's probably core supplements. I mentioned some: caffeine, fish oil, vitamin D, the sort of health-based ones. Protein's convenient. Creatine probably works. I would definitely use that. Not probably works, definitely works. I'm a big fan of beta-alanine, but then I showed you some examples of supplements which are novel and can't always guarantee that they work, right? A lot of supplements are just simply overhyped, to use an internet term. And just be aware that they can be contaminated, they can be adulterated, and you could potentially have an alternate use of the resource. I'm going to finish it there. Thank you very much for your attention to my 2 lectures on dietary supplements. I hope you find it useful. Great thing about this being online is that you can pause this at any point. You can go back through and have a look at these things, stop, start it, have a think, and please do go and investigate the individual studies and decide for yourself. I've been Dr. Andrew Chappell, and thank you for your attention.